Hello and welcome to Video Podcast 9.4. In this podcast, we will tour the ocean floor. In our previous podcast, I overviewed two types of continental margins, namely active continental margins and passive continental margins. I'd like to discuss a feature associated with active continental margins in a little bit more detail, namely deep ocean trenches. Deep ocean trenches are long, narrow troughs that are the deepest parts of oceans. These are sites of plate convergence, and they are found predominantly in the Pacific Ocean. When we talk about plate convergence, we are talking about a moving lithospheric plate that is subducting and plunging into the mantle. This subducting plate can trigger volcanism and earthquakes in the surrounding area. I've already mentioned that deep ocean trenches are the deepest parts of oceans, but it is hard to wrap your mind around just how deep these things really are. As an example, the Mariana Trench, which is shown on the screen, is over 36,000 feet deep. And just to kind of put that number into perspective, that's as deep as 120 consecutive football fields lined up end to end. Now I'd like to shift gears and focus on two prominent features of deep ocean basins. For starters, I'd like to discuss Abyssal Plains. Abyssal Plains are incredibly flat features on the deep ocean basin. In fact, these are some of the flattest places on planet Earth. They consist of thick accumulations of sediment that have buried an otherwise rugged ocean floor. It's also important to note that you'll find more abyssal plains in the Atlantic Ocean than you will in the Pacific Ocean, and there's a reason for that. The Pacific Ocean contains a lot of deep ocean trenches, whereas the Atlantic Ocean doesn't. You can think of deep ocean trenches as kind of like garbage disposals for sediment. So in the Pacific Ocean, where there are a lot of deep ocean trenches, there are a lot of locations to throw away sediment, loosely speaking. A second feature of deep ocean basins that I'd like to overview are seamounts. Put simply, seamounts are isolated, steep-sided volcanic peaks. I like to think of them as looking like little upside-down ice cream cones, minus the ice cream. Some seamounts form in association with volcanic hotspots. As an example, the Emperor Seamount Chain, which is shown on the screen. Others are born near oceanic ridges, which I'll be discussing momentarily. It's also worth noting that some seamounts will grow tall enough to emerge as islands, a prime example being St. Helena, which is shown on the screen. For the remainder of this video, I will shift my attention to the mid-ocean ridge. There's a relatively popular misconception that the ocean is kind of like a big bowl of soup, which is deepest in the center. But the existence of the mid-ocean ridge completely destroys that misconception. By definition, the mid-ocean ridge is a broad, linear swell that occurs along divergent plate boundaries. I'd like to emphasize that the term ridge is misleading, because when we think of a ridge, we think of what would be a narrow feature. However, in spots, the oceanic ridge can be as wide as 2,500 miles. Interestingly, the oceanic ridge is the longest topographic feature on planet Earth, and stretching over 43,000 miles in length, it accounts for 23% of Earth's surface. As shown on the map on this slide, the mid-ocean ridge runs through all four of Earth's oceans. There are two really important things I'd like to discuss regarding mid-ocean ridges. First, I'd like to explain why the mid-ocean ridge is an elevated feature. And as is often the case in Earth science, there is a fundamental concept that seems to explain quite a bit of what we see in nature. In this case, we are talking about density. The mid-ocean ridge rises because newly formed oceanic lithosphere is hot and it's less dense than the cooler surrounding rocks. Putting it as generally as possible, warm things tend to rise and cool things tend to sink. So at divergent plate boundaries, where the seafloor is spreading, that newly formed lithosphere is really hot, and being hot, it wants to rise. A second point that I'd really like to emphasize on this slide is the one associated with rift valleys. Rift valleys are deep, downfaulted structures, and they're termed rift valleys because they look so strikingly similar to continental rift valleys. As an example, the East African Rift Valley is shown on the screen, and rift valleys associated with the mid-ocean ridge look just like the one shown on the screen, only they're underwater. Some features of rift valleys include volcanoes, underwater lava flows, and black smokers. So to conclude this vodcast, I'd like you to consider this concept map overviewing ocean floor provinces. There are 3 provinces of the ocean floor, specifically Continental Margins, the Deep Ocean Basin, and the mid-ocean ridge. Continental margins are what you'll find closest to the shoreline, and there are two types of continental margins, namely active and passive. Active continental margins occur at convergent plate boundaries, and they are associated with earthquakes and volcanoes. Passive continental margins are geologically inactive, and there are three prominent features to passive continental margins, namely the continental shelf, the continental slope, and the continental rise. Now let me shift your attention to the deep ocean basin. The three features that we've discussed regarding the deep ocean basin are seamounts, abyssal plains, and deep ocean trenches. Seamounts are isolated volcanic peaks, and they are associated with both hotspots and divergent plate boundaries. The abyssal plains are some of the flattest places on planet Earth, and they are places where sediment accumulates and flattens out an otherwise rugged ocean floor. The third feature of deep ocean basins that we discussed were deep ocean trenches. These are the deepest locations in our oceans. They are sites of plate convergence, and they are very long, narrow features. The final ocean floor province that we overviewed was the mid-ocean ridge. The mid-ocean ridge is a broad linear swell that occurs along divergent plate boundaries. Really important features associated with oceanic ridges are rift valleys. And rift valleys are deep, downfaulted oceanic ridge structures. So hopefully this concept map serves as a really good summary of the three ocean floor provinces that we've covered in the previous two vodcasts. Okay, that concludes this video podcast. In our next video, I will overview ocean circulation patterns.